In this video, we are going to combine a lot of things that we've already learned into graphing quadratic functions. We'll also state the domain and range and identify key points on those graphs. To graph a quadratic function, we need to find the following information. The vertex, that is the point hk. And we can do that by either completing the square to find the vertex form or use a vertex formula. And we need to know also if the vertex is going to be a minimum or maximum point. So if the parabola opens up, keep in mind that the vertex in is going to be the minimum point on the graph, and therefore k is the minimum value of the function. If the parabola opens down, then the vertex is at that peak, and so it will be a maximum point, and therefore k would be the maximum value of the function. The other things that we need to find are key points that we found throughout the course. The y-intercept, we find the y-intercept by letting x equal 0 and solving for y. And in function notation, that is the same as evaluating the function when x is 0. To find the x-intercepts, we let y equal 0 and solve for x. And therefore, the x values are actually solutions of the equation p of x equals 0. Then we also need to know if the parabola opens up or opens down. If the value of a is positive, positive means it opens up, right? Opens with a smile. And if a is negative, it opens down, it frowns. The axis of symmetry, so the parabola has a property that the vertical line through the vertex gives us some symmetry to the left and right side of the vertex. And so we say that this is an axis of symmetry, and it is just the equation x equals h, which is the vertical line through the vertex. Then we can also identify the domain and range of a quadratic function. The domain of any quadratic function is a set of real numbers that is from negative infinity to infinity. The graph extends infinitely to the left and right. The range depends on the direction the parabola will open. If the parabola opens up, like I've illustrated here with this first graph that has a vertex of hk and it goes up, so the range is from that y value of k on up to infinity since the parabola opens up. If the parabola opens down, that vertex point hk is the highest point, and then everything is below that. So the y values start in the negative infinity direction but go up to a maximum value of k, right? So it depends on if k is your maximum or minimum value. So in example 3, we're going to see two examples of graphing a parabola. Now, of course, you could put these parabolas in your calculator and graph, but you would need to be able to find all of these key points and answer some additional questions that the graph is not going to tell you, or the calculator will not tell you explicitly. So we want to graph, we want to identify the vertex, intercepts, axis of symmetry, domain, and range. In fact, I have a chart that we'll go through and complete. And the first function is p of x equals the opposite of, in parentheses, x minus 3, close parentheses, squared plus 4. The first thing we want to identify is the vertex. Well, because this is in vertex form, the vertex is just 3, 4. Then we want to state the direction of the parabola. Because we have this negative on the outside, that's understood to be a negative 1 as a coefficient of the square term. Since a is negative 1, the parabola will open down. And then, is the vertex a max or min? Well, that's dependent upon which direction it opens. Since the parabola opens down, the vertex is at the peak, so the vertex is a maximum point. And then what is the maximum or minimum value? Well, the max value is the y value of the vertex, so the max value is 4. There's no minimum value since the graph extends infinitely downward. Now to find the y-intercept, This is where we let x equal 0, so that is we find p of 0. P of 0 is the opposite of 0 minus 3 quantity squared plus 4. So we have the opposite of, and then in parentheses, 0 minus 3 is negative 3 squared plus 4. We simplify in parentheses to get the opposite of 9 plus 4, which is negative 5. So the y-intercept is the ordered pair 0, negative 5. Then we need to find the x-intercepts. So the x-intercepts are found by letting y equal 0. So that is, we set the opposite of x minus 3 quantity squared plus 4 equal to 0. And just remember all of the things about solving quadratic equations. We have an expression squared, and that's where the variable is contained. So I would suggest using the square root property to solve this equation. We can do that by first subtracting 4 from each side, so we get the opposite of x minus 3 quantity squared equals negative 4. Now we have a negative 1 on the coefficient of that squared expression, so we need to divide each side by negative 1 before we apply the square root property. So this will give us x minus 3 quantity squared equals positive 4. So now something squared equals a number. The square root property tells us that x minus 3 is equal to plus or minus the square root of 4, which is plus or minus 2. So therefore we get that x minus 3 is equal to 2, or x minus 3 is equal to negative 2. Add 3 to each side to get x equals 2 plus 3 or 5, or negative 2 plus 3 is 1. So I have two x-intercepts at 1, 0, and 5, 0. The axis of symmetry is just going to be the vertical line through the vertex, so that is x equals whatever the x value of the vertex is, which is 3. The domain of any quadratic function is all real numbers, negative infinity to infinity. And then the range, we might want to wait till after we get the graph, but just think about this. We know that 3, 4 is a maximum point. The graph extends downward from that 3, 4. So our y value of 4 is a maximum value. So that means our range is going to be from negative infinity to 4 with a bracket. And now we want to graph this function. And let me write it again. It's the opposite of, p of x is equal to the opposite of x minus 3 quantity squared plus 4. And so what I just learned is that the vertex is at 3, 4. So I have a coordinate system on the screen. I'm going to plot the point 3, 4. I will plot my x-intercepts and y-intercepts. So my y-intercept was 0, negative 5. I had an x-intercept of 1, 0, and 5, 0. And then I have this axis of symmetry that is a vertical line through x equals 3. And I'm going to draw that on here first, and I'll show you why. Because what the axis of symmetry tells me is that if there's a point to the left of this axis of symmetry, there needs to be a mirroring point to the right of it. And we can see that, like the point 1, 0, and 5, 0. Notice that 1, 0 is 2 units left of the axis of symmetry, and 5, 0 is 2 units right. So likewise, this point 0, negative 5, it is 3 units left of this axis of symmetry. So that means 3 units right of that, I need to have a point that's in the same position. So at 6, negative 5, there is a corresponding point on the graph. So then I'm going to connect these dots to get the graph of the parabola through these points. And so from this graph, we can confirm the range is from negative infinity up to a y value of 4. Now we have another example. P of x is equal to x squared plus 4x minus 5. This parabola or function is written in the standard form. So the first step is to find the vertex. In this case, because it's in standard form, we probably want to use the vertex formula. This would tell us that x is equal to negative b divided by 2a, which in this case a is 1 and b is 4. Therefore, we get the opposite of 4 divided by 2 times 1, which is negative 4 over 2, or negative 2. Then the y value of the vertex is found by plugging the negative 2 into the function in place of x. P of negative 2 is negative 2 squared plus 4 times negative 2 minus 5. And this gives us 4 minus 8 minus 5, negative 4 minus 5, or negative 9. So our vertex is the ordered pair negative 2, negative 9. The direction of the parabola, the value of a is 1, which is positive, so the parabola will open up. Does this make the vertex a max or min? Well, because it's opening up, the vertex is going to be the lowest point, which makes the vertex a minimum point on the graph. And therefore, we have a minimum value, which is the y value of the vertex, which is negative 9. There's no maximum value because the graph extends infinitely up. Now we are asked to find the y-intercept p of 0, right? We just let x equal 0. It's 0 squared plus 4 times 0 minus 5, and that is simply negative 5. So the y-intercept is 0, negative 5. The x-intercepts are found by setting the function equal to 0. So x squared plus 4x minus 5 is equal to 0. And if you need to remind yourself of different ways to solve quadratic equations, you can look in the prerequisite skills for section 14 or go back to section 3. But this is a quadratic equation that we can solve by factoring. If it doesn't factor, we would have to use a quadratic formula. If you want to use a quadratic formula initially, you can certainly do that. The factors of x squared are x and x. And then the factors of 5, whose difference is 4, are 5 and 1. Keep in mind that the negative on the last term means we have to have different signs in the binomials, with the larger one being plus since it's on the plus 4. So therefore the factors are x plus 5 times x minus 1 equals 0. Setting each of these factors equal to 0, we get x plus 5 is equal to 0, or x minus 1 equals 0, which gives us x is equal to negative 5 or 1. Therefore, my x-intercepts are 1, 0, and negative 5, 0. The axis of symmetry is again the vertical line through the vertex, which is x equals the x value of the vertex, which is negative 2. The domain of any quadratic is all real numbers, negative infinity to infinity. Then the range, think about this, our vertex is our lowest point and the graph opens up from there. So we have this minimum value of negative 9, but the graph extends upward to infinity. So bracket negative 9 to infinity. And so now we want to plot all of this information on a coordinate system to get the graph. Our function is again p of x equals x squared plus 4x minus 5. Now let's plot the information that we just found. We have a vertex of negative 2, negative 9, so left 2 and down 9. We have a y-intercept of 0, negative 5. And then we have two x-intercepts at 1, 1, 0, and negative 5, 0. And then also keep in mind that we have this axis of symmetry, that is this vertical line drawn through our vertex, so that is a vertical line drawn through negative 2. So here again, it's going to help me identify some other points on the graph. Notice that to the left and right of the axis of symmetry, if I go left and right 3 units, I get my intercepts. Notice that if I go right of the vertex to 0, negative 5, that means I should be able to go left of the vertex 2 units to get to another point on the graph, which is at negative 4, negative 5. So now we want to connect those points to get the graph.